solving a system of equations, these are going to be lines. So, if the equation of the line is not in a type of form that you recognize, so for example, this isn't in any particular form, then you might want to put it in something like slope-intercept form. So to do that, you would add the 8 and then divide by 2. Okay? And you notice that we get the same thing as equation 2. So you don't need to graph both because they're the same line. You just need to graph one. So to graph this, you have a y-intercept of 1, 2, 3, 4. From there, you're going to go either up 1 to the right 2 or down 1 to the left 2 because your slope is positive 1/2. Okay, so what you would do is you'd graph this line, then you would graph the other line. Well, the other line is the exact same line, so you don't really need to graph them. Okay, but just to kind of show you, if you get one line and another line and they're the same line, how many times are they touching? All the time. So you have infinitely many solutions or all real numbers. Somewhere you need to write what your answer is. Many people on this last quiz did not put what the answer was. When you're solving a system of equations, you're looking for what? What is the solution on a graph? The intersection point. Okay, so when you're solving a system of equations, by graphing, you're looking for the intersection point. There is not a single intersection point. There are infinitely many intersection points. So somewhere you need to answer the questions. Okay, it says solve. Okay, number 2 is an inequality. There isn't really an answer solution for this. Your graph is your solution, but there will be some kind of question that asks, is blah 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 a solution? Okay, I'm going to graph the first one using x and y intercepts because the coefficients go into the constant, so it's easy to do intercepts when that happens. Okay, to find your x-intercept, you're going to plug 0 in for y. So when you plug 0 in for y, this whole term goes away. So I have x equals 6 left, so your x-intercept is 6. So 1, 2, 3, 4, 5, 6. Okay. Then to find your y-intercept, you plug 0 in for x. So when you plug 0 in for x, all of this goes away. So you get -3 for your y-intercept. This is a system of inequalities. It's not a linear programming one, so you can't just automatically know that it's a solid line. You have to check this. This is a dashed line. If it says less than or greater than, it's a dashed line. If it says less than or equal to or greater than or equal to, it's a solid line. If you're trying to figure out where to shade, you can test a point. The easiest point to test is 0, 0. So what you do is you plug in 0 for x and y, and then you determine if that is true or not. So you get 0 is greater than 6. Incorrect. So this is where 0, 0 is. If it's not true, you don't want to shade it because that would mean it's a solution. So you're going to shade this way. Okay, next line, I'm going to graph using intercepts again. So if you plug in a 0 for y, what do we get? -4. So -4, 0 is my x-intercept. So 1, 2, 3, 4. Okay, if you plug 0 in for y, what do you get? -1. Be careful when you're covering this up, if you're doing the cover-up method, that you don't cover up the sign too, because if it's negative, that changes it. Solid or dotted line?
Solid.
Solid, because it's got the or equal to right here. This is also false. When you plug in 0, 0, you get 0 is less than or equal to -4. That's not true. Okay, so if this is where 0, 0 is, we don't want to shade this way. We want to shade the other way. So we're shading down here. You can test any point you want. It doesn't have to be 0, 0. I just picked 0, 0 because it's the easiest one to test. Now, there is a question here. It says, is 0, 0 a solution? Make sure you answer this question. What's the answer?
False.
No. If you don't answer the question, guess what?
You're wrong.
Well, you're going to miss points. That's part of the problem. You have to graph and then answer the question. If you just graph and you don't answer the question, you didn't answer everything.
No.
Yeah.
Big bag
So
of
for
nails.
a point to be like a solution, has to be on the line or in the shaded
It has to
area?
be either on both lines or in this double shaded area. So if it falls in here, it's not a solution to the system. If it falls in here, it's not a solution to the system. If it falls on the dotted line in the shaded area, it's not a solution. But if it falls on this line in the shaded area, it is a solution because this is a solid line. Okay?
So on this test, can we just put like a big no right next to the question?
I think I put yes and no and you just circle it.
Oh, okay.
4, 5. You're going to solve algebraically either using substitution or elimination. It's up to you what you want to do. You can simplify equations if possible. You can multiply equations if necessary.
Substitution.
What do you want to do?
Substitution.
You want to do substitution?
Elimination.
What's the substituting
Okay,
part?
so if you simplify it first,
So it's substitution.
1
Wow.
simplifies to, if we divide by 3, 2x minus y equals -4 when you divide by 3. 2, we can divide everything by 2.
Negative 2
Negative 2x
plus 1
plus y
equals
equals
3.
3.
Yes. Substitution.
But they all
So
cancel
it's
out.
easier to do elimination.
Substitution.
If you add,
Ah,
They all cancel out.
you'll see that this
Okay.
cancels, this cancels. So what's left on the left?
0.
0.
Oh,
See,
yeah.
I'm
What's left on the right?
0. Oh my god.
Not 0.
Negative.
Oh,
It's
no.
-1.
It's -1.
This is a false statement.
This is a false statement which implies
No
No
solution.
no solution.
That was freaking heck out.
What if it's true?
Then it's the
Then
true
it's identity.
solution.
Then it's
all
all real numbers.
Dang.
Infinite
called a
unknown.
tautology when you say like 0 equals 0.
Holy heck.
It's actually just called the true statement.
Typically we just get one solution.
Or not.
Your best option for this particular question, because both y's are solved for, is to take this guy and substitute it in for that y. Now, if it's not solved for, you might want to solve for it and then do this process. So what you're going to get is 2/3 x minus 1 equals 2 times the absolute value of x minus 1 minus 3.
Yeah, so add 3.
So add 3. So 2/3 x plus 2 equals 2 times the absolute value of x minus 1.
And I divide by 2.
What are we not going to do?
Distribute.
Right, don't distribute. So instead, multiply both sides by a half.
Why'd you just divide each by 2?
Because there's
Do you know how to do that with fractions?
Yeah, you just do 2/3 times 1/2.
Right, so what did I just do? I just did that. Listen, you do you, I do me, it's fine, we'll meet in the middle.
I don't like this.
Our objective is to get the absolute value by itself. Once we get the absolute value by itself, we split it up, okay? Now, you guys are used to looking at it this way, okay? All of chapter 1, it looked like this, right? Do you remember?
Yes.
You were used to the absolute value being on the left. Okay, then we took x minus 1, we set it equal to the right, and then x minus 1, and we set it equal to the opposite of the right. What's inside the absolute value doesn't change. What's outside on the other side of the equation, what it's equal to, changes because that value on the inside, we're determining if that value inside is positive or negative. Okay, so then you solve each one. So I'm going to add 1 and subtract a third.
X equals 2/3.
So I got 2/3 of x is equal to 2. And then probably multiply by 3/2. And that gives me 3 for x. Now remember, we're solving a system of equations, right? So a system of equations has an x and a y. What is the y that goes with 3?
0.
No.
Oh wait.
So we want.
Hold on.
It would be, if you take it and plug it back in,
Plug it back in, you get the Y.
woo!
Substitute.
Over there, you get what?
Wait.
You get 1.
2. Yeah.
Get 1. 1 was right. Solid guess.
An educated guess.
Now we're not done. We still have to solve the other one, but that's one of the answers. You do want to check these. There could be extraneous solutions.
So what's that mean then? Extraneous?
It's when you get a solution, but doesn't actually work.
This is what we have to do question on the test.
And then you say true or false.
Let's solve this one over here. Okay, we're going to add 1 again, and we get 0, and then we're going to add a third. Okay, and if you suck at fractions, it doesn't really matter because this is going to wind up being 0 anyway.
Oh my god, I'm bad.
So y would equal -1.
Yes. So 0, -1. You got 2 intersection points. Okay, there is a way to check this on your calculator. I dare you to go home and practice.
Okay.
I true.
So you can graph them and see where they intersect. I don't know.
Good job.